All right, welcome back to what's going to be episode 2 of this catting series. Just as a reminder, we are catting a 2022 FRC robot, just to use as a good example to show how you design around fairly simple systems using things like balls and such, which compared to some other years ends up being a little bit on the easier side, usually paired with something that's a little bit more tricky. So our main goals for this are we're going to have an overbump intake. We're going to be shooting our cargo, which are the balls we're using, which we'll get to look into more of today. And we also want to be able to do the big scary climb that they did for that year. So for main systems we're doing, we have some limits down here that we've set. We've set our frame is going to be 26 by 26. We've said we're going to be using swerve, and we said what swerve we're going to be using. So there's some other limits we're going to be adding today, just so we have everything kind of fleshed out. So what I'm going to do is, we also have our manual here, which was the perfect size, but now it's not. Oh, there we go. Perfect. Right size for what we need. And before we get too deep into this, I want us to kind of talk about our layout for our robot. So, end goal, what we're trying to accomplish is we want to be able to intake a game piece from the ground. We want to be able to put it into our robot, and then we're going to want to be able to shoot it out eventually, right? So that's kind of our overall goal. Now, if you're familiar with the 2022 season, you will also know that if I come over here, let's see if we can look for the cargo. Right here it is. So if we look at the cargo, you can see here that we have two different colors of cargo. And the different color that you scored, if you were on the Red Alliance and you scored a red ball, you got points for yourself. But even if you were a red team robot and you shot a blue ball, you're actually scoring points for the blue team. So this year, it made sense to be, rather than just shooting any balls you want, it made more sense to be focusing on only your color. So there's an added level of filtering that teams had to account for in this year. So for our intents and purposes, we'll talk about that a little later, but we aren't going to have to think about this too much in our current design, and it will end up just kind of working out for us. So now, at this point, it's worth noting that if you look at a lot of the robots for this season, one thing that you'll immediately notice is that there are a lot of one-sided ground intakes. I can spell right. And that's because these work great. When you have big parts like that, or big balls, I mean, it is really easy to just kind of rotate your robot around and go and grab them. We're going to be doing 2 takes on this. And what we're going to do is we're going to have a take on doing it from one-sided, and we're also going to have a take on doing it from 2 sides. And the reason I'm doing this is, most of the time, what you're going to end up doing is you're going to be doing a one-sided ground intake. It's a lot more common, and it works amazingly. And there's a reason it's so common. It's because it's tried and tested. We know it works. But that being said, there is some warrant to being able to do a 2-side ground intake, because you have less rotation you have to do, which means you can speed up your cycle time, especially in a game like this where your overall field is... See if I can pull it up somewhere on here. Go back up to the top. Oh, I just went right by it, didn't I? Good job, Ben. There we go. I'll zoom in so you guys can see too. But this is a big open field, and balls can be anywhere. So anytime you can save by not having to rotate your robot by a full 180 degrees to pick up a ball, that's going to be a big difference. If you only have to rotate by 90 degrees, that's a huge game changer in your ability to shoot as often as possible. So we're going to be going about both routes. The one we're focusing on this video, and to start with, is we're going to be focusing on just a one-sided intake. So we'll keep that in mind for this, and then later on, once we are done with this design, we'll then go back and we're going to reiterate things, and we're going to design for a 2-sided ground intake. That being said, we'll continue from where we are here. Now, one thing I want to note that I didn't mention in the last video is if you look in the upper left corner, you're going to see we have our sketches, and these reflect the different parts of our sketch each. So what we need to do is we want to rename these so that they better reflect what we have in each sketch. And this isn't a big deal. And at the end of the day, if you don't change this, it's not going to completely destroy the experience for anybody. But when we're doing this CAD, the big reason why we're doing this all is so we have an example of our robot. And if you don't have an accurate representation of your robot, then you might as well not be doing the CAD in the first place, because you're not really achieving anything with it. So we're going to keep that in mind. These are now renamed, and I'll be continuing to try and keep myself accountable to make sure I keep doing it. And if I don't, I'll make sure I do it in the following video of whenever that happens. So what I want to start with, though, today is we want to start thinking about intaking our balls. So what I'm going to do is I want to kind of have a general idea on how we're going to have the cargo flow into our robot. So it's going to be really handy if we can have an example of the ground. So what I'm going to do, I'm going to draw a big line, and you can actually see the right circle is highlighted, the right wheel is highlighted, and over by my cursor you can see there's a little icon, and what that's saying is right now the line is tangent to that circle. So if I make it and now I move it, you can see it's always going to move along that circle, which is handy because it means it's always going to be touching the base. So what I can do now is I'm going to click this wheel and this line, and I am going to click T, which you can also accomplish by coming up here and clicking tangent. But I can click T on my keyboard, do that. So now we have it on the floor. Our whole robot's on the floor. I'm going to take this line, I'm going to turn it into a construction, which is Q. Construction lines are lines that have no bearing on creating shapes and stuff, and they just kind of work as a reference table for you to have. And now we have our floor. So I am going to have that there. And what we're going to do now is we are going to throw in a piece of cargo. Now, if we come look over at the, whoa, okay, there we go. Go up to the top. We're going to refine the cargo page, which shouldn't be too hard. There we go. If we look in here, we can see it's a custom modified piece, and the cargo is 9.5 inches in diameter, which is going to be what we're worried about for right now. Weight we'll want to look at later, possibly, but for the time being, we just need to worry about the full size. So 9.5 inch diameter is going to be really easy for us to translate over into here, because all we have to do is make our circle, dimension it, I'm going to say 9.5. There we go. Now, this is going to be a reference circle. So the cargo is not going to be something that's actually on the robot. Rather, what it's going to be is an example of a block in the robot. So what I'm going to do is, similarly to what I did with the ground, I'm going to make these also construction. And along with this, I know that at least here on Earth, because of Newton's laws, this is not going to be just flying in the air. Okay, so I want to mount this to the ground entirely. So I'm going to do the same thing I did with these circles. I'm going to make that tangent to there, and now it will always move along the ground, which makes sense because this very well reflects what your cargo will mostly be doing. Now, does that mean that there's not a chance that when you have a cargo, it's going to be possibly bouncing around? Yeah, that's true. That is a possibility. But we're going to consider those things as we go along, and you'll see that we're going to slowly figure out ways to work around that. Now, the thing we want to think about with this is these cargo are going to be in a lot of spots throughout the robot. So we want to count from the ground, when it's on the ground, all the way until it's in the robot and leaving the robot. So what we're going to do is we're going to add in more cargo. And to make sure that we cover the most surface area, we're just going to add a whole bunch of circles. We're going to make them equal. And now what we can do is we can set them tangent to different areas. So here we can see these two are tangent to the ground still. I bring this over here. I'm going to assume that when I'm intaking from the ground, I'm going to have some form of wheels up above it that are going to pull it in, and I'll use the bumpers as a backing to kind of help pull it in the rest of the way. So that in mind, since I know that our cargo is going to be pushed up against our bumper, I can also make those tangent. And we'll see here, I make a tangent on this arc because that's the point where it actually contacts. If I made it on this line down below, it would actually slightly be further that way. Not a big deal. You're talking about very, very low, very, very high tolerance right there. But it's better to do it the right way so that later on when something gets messed up, you just have one less thing you have to worry about. Now we have that. We'll take these 2 points too. We'll make those tangent. And now you can kind of start to see the path that our cargo is going to start taking. Now, one thing we'll notice immediately as soon as we start drawing this next one is based on where it exactly is, we're going to be running into issues with running into our swerve. So something I want to think about now is we're going to be actually leaving this sketch, and I'm going to rename this to cargo path. There we go. And now we have that done, we're actually going to be looking at this from a different perspective. So obviously we've been focusing on looking at the robot from the side. Now what we're going to do is we're going to flip it, and we're going to look at it from the top to kind of get a better idea on where things are in terms of the robot. Now, what we're going to do to start this off is we're going to create a new sketch on this plane. And to start it off, we know that from our previous documentation that our limit is 26 by 26 frame. So with that in mind, we'll go and we'll make this 26 by 26 frame. 26. And we will be using 2x1 for our project. So I know the top's going to be 1 inch. So right here, I'm just going to put a 1 inch. And now we have a 1 inch base. Oh, would you look at that? That lines up with our frame pretty well. Oh, that's kind of cool. And now you can kind of see that even though we're just doing 2D sketches, we're starting to come up with something that's a lot more 3D. And it's a little hard to look at now, but as we get further and further along, you're going to see even more and more just how impactful it is that we're able to have all these sketches that we can use once we finally get into the final parts of this design. So, I'm not completely done yet, because I still have big swerve modules in the corners I got to account for. So, go back over to main, which we did in the last video too. And all I'm going to do is we went over measuring tricks. I'm going to click on this line over here. The whole part is highlighted, but you'll see if you look pretty closely, you can see that this line on the right side is slightly thicker. It's kind of hard to tell, but by knowing that, I can know that's all the way we're measuring from the furthest end on this side. And it looks like it's going to be hard to find an exact point to measure from here. I'll try. We'll see what we get for a max distance. Well, that max distance isn't very helpful for me. Center distance, that might be more helpful. Position, that's not going to help, so we'll stick with show all. And since none of these are like super helpful, we're going to use center distance, which we can see we're 6 inches from the center of this bigger circle. So we'll keep that in mind. I like to jot this down just so I don't forget. Inches from to of circle. And then what I can do is I can just measure this area specifically. Again, you can see if we really kind of zoom in. Zooming in doesn't help either. But you can kind of see it's slightly thicker over there. We can see that we get a radius of 1.1875 in the bottom right corner. So we're going to have a radius equals 1.1875, which seems like a weird number, but if we were to calculate that out, which I'll do quick just because I'm kind of interested, let's see what happens is we take 1.75 times 2. That ends up being 2 3/8. So not actually that scary of a number, but that's kind of where that radius is coming from. So now what we can do is we can just do 6 plus the radius, which is just going to give us 7.1875 from edge to inside edge. So we're going to pretend I spelled that right. Oh boy. So, now we have all that done. We can now go back into our 2D sketch, and we can add in our box regions in the corners. So, I'm just going to do 2 lines like this. I believe that one's intersecting. Yep, it is. You can set these both equal to each other because these modules are just a big box. So, it's the same distance from this outer edge to here as this outer edge to here. I could show you how. It's not too hard to figure it out just by doing the quick math. So I'm just going to leave it alone for now. But I know this needs to be 7.1875, I believe, which I will also double check just in case. 7.1875, perfect. And now I know that's right. What I can do is I can take these 2 lines. We're going to be using a new tool. I'm going to come up to my top bar, and I'm going to see a little icon with 4 boxes, with the upper left one being white. And I'm going to click on this down arrow, and I'll see a circular pattern option. When I click on this, we'll see that we have this little box in this area, and when we move it around, we get 3 different angles of the exact same, rotating around this square that I'm moving around. So, I know this is a full square, so I know that I can do this rotation around the center. So I'm going to put it like that. And down here, we can see this is the number of iterations we do in that circle. So in my case, I want to have 4, which includes the one we've made. So we're making 3 new ones, plus the one we already have, which gets to 4. And now those are all in their corners. I will left click, and you're good. If you click the check mark up here, it will close the sketch. It'll still do your stuff, but it'll just close the sketch, and then you have to reopen it. I only say that because I do it all the time, and I feel quite silly when I do it. But just so you guys know, that's not like a thing that you should be surprised or concerned if you do a lot. So now we have that. We can kind of see our frame. We have a better idea on where the swerve modules are, and we kind of have a better idea for where we're kind of limited and where things can go. So I'm going to do a quick check mark right there. And on this top plane, I'm also going to put in our bumpers just because it's nice to have them marked. So what I'm going to do is I'm going to click all these 4 lines. And because I know they're going to be the same as what I want to use, I'm going to click the button U on my keyboard. And by clicking U, it's going to take those 4 lines. It's going to create them. So now what I can do is I can add some more lines out up top. I'll do one up here, and then we're going to be able to replicate this all the way around again, like we just did with our circular pattern. 4. We're going to make sure it's in the center, like that. And click that. And now you can also see these are all going to move together. Well, ain't that fancy. Now, I don't remember exactly how thick this needs to be. So, the handy thing about this is we've got a nice sketch right here that shows me. So, if I click from this line to this line, we get a measurement of 3.25 inches. Perfect. That's exactly what I needed. So, I'm going to go in here. We'll go back to looking at the top plane. I can set this to 3.25. There we go. And now, I'm going to come up here. You'll see an icon for a little 3-point arc, which you can also activate using keybind A, which is what I'm going to do. We're going to do this. We're just going to put in each of the corners. This one, you could do the same process of just replicating it for all 4 of the corners, doing 1 and then doing the rotational pattern. But that also ends up working out well. So there we go. Now we've got these 2 sketches, which show our kind of top path. And now I'm going to go back. I'm going to rename these. So I'm going to name this frame top. I'm going to rename this to bumpers top. And I'm actually going to rename our frame and bumpers one from before so that they also better reflect what we need or what they are meant to be representing. So, bumper side. All right, perfect. Now, the nice thing about this is if we want to look at certain sketches but not others, we can come over to this left side and we can hide different ones. And by doing that, we can isolate into specific sketch ideas. And so now we can see we're only looking at this face Whereas if maybe I wanted to look at just the top, I didn't want all the other clutter, I could hide the other three, and then you're just left with that and your top frame vision. You can also hide the planes if you want. The only thing with that is when you hide them, then you're going to have to go into the top left corner in order to start sketches on them. So I usually just like to leave them open. For our cases, we don't really need the front one right now. So you can kind of just leave it at right and top, and then you're good. But for right now, we're just going to keep everything open so you can kind of see it. So now we've added all this stuff in, I want to kind of look at this top section, and I can see, okay, well, I'm going to click in on frame top. We're going to start looking at this again. One thing I notice is, let's say that I have a ball coming in from somewhere out here, right? Okay, same ball as before. Give me 9.5. It's going to be construction geometry. We're going to be able to just kind of barely fit in if we just have it be able to be kind of centered, which is quite nice. However, a good rule of thumb when you are designing a ground intake is you want to be able to pick up probably at least two of the game piece right next to each other. And the reason for this is because when you're coming at a game piece, they could really be anywhere. It could be over here, over here, over here. There are all sorts of spots they can be, right? And our goal with our intake is we want to have an intake that can pull in from any direction with the most ease. And for our case, what we're finding with this is we're going to see that the wider we can have our intake be, the better off we're probably going to be. So if I measure this from edge to edge, we're going to go into our measure options. And if I go to max distance, I can see that there's a line from the furthest edge on one side to the furthest edge on the other. And I can see that max distance is about 19 inches. So with that in mind, I would think it'd be nice to have another inch of clearance probably, just in case. So I'm going to say that we'd probably want it to be just about 20 inches wide. Okay, so I'm going to delete these, move this down, and I'm just going to put in a line to kind of exemplify what we want. If you come up to the top left corner and you click on the down arrow by the line picture, you'll see a midpoint line option. If you click on this and you click somewhere centered, you'll see if I hover over this middle dot and then I pull down, a little orangish yellowy dotted line shows up. I can use that, click down, and then as I pull my cursor out, it's going to do equal amounts of length on both sides. So I'm going to draw this. I'm going to dimension this to be 20. And we'll see, as we're going to pull it in, that should be just good to allow for a ½ inch clearance on both sides and allow for us to pull in the mini balls. So that's good. So now we've kind of seen that. What I'm going to do is, if we go back in, the way I've done this will work for what we need, but I did not follow the correct procedure that I've been talking about, where I have all these things in different sketches. So what I am going to do is I'm going to delete that from this one, just because we probably shouldn't have it cluttering it. We're going to create a new sketch on the top layer, and I'm going to recreate the whole thing I just did, but I'm going to do it on this other sketch instead, just to make sure that we keep everything separated. It can get really easy to not think about this and then just kind of keep going. And for all intents and purposes, it will work the same. The only problem is that when you go about it that way, things will start to get a lot more confusing. You'll have a lot more lines you have to deal with, and there's just going to be a lot more clutter. So I found that most of the time, it's nice to be able to just kind of have everything in their separate areas so that we can have a better idea on how to get everything put into the robot and such. And it helps to make it so that as we find stuff that we don't want to look at, we can just hide it. And that's good. This sketch, I'm going to rename to, we'll say, cargo path top. And that means we'll go back and we'll rename this cargo path side. Now, it doesn't seem like we've done a whole lot in this video immediately. But basically what we've accomplished is we've now determined not only what we want for our side view to be, but we've also determined what we're going to eventually want for our top path to look like too. So in the next video, what we're going to do is we're going to start looking at how we're going to take these two motions and starting to throw together something that we can actually shoot cargo with.